You can think of this video as part 2 of dimensional analysis using mixed units. Mixed units you have used so many times. They are any unit that you have to verbally say the word per in it. For example, if you are buying meat at $7.99 per pound, that is a mixed unit. There's technically two different units, the dollars and the pound. So if this was a conversion factor, we would want to split up those two different units, one in the numerator, one in the denominator. So this would be $7.99 in the numerator and 1 pound in the denominator. And of course, you could flip that around if need be, if you needed to cross cancel the dollars. Another example is if you're traveling down the road at 55 miles per hour. You have two units there, miles an hour. And again, if we're writing this out in dimensional analysis, we want to split up those two units, one on top of the fraction and one on bottom. So those are examples of mixed units. Density is another mixed unit common in chemistry. For example, the density of copper is 8.96 grams per milliliter. So writing that out as a conversion factor, split up the grams from the milliliter. Most often, the number on bottom is a 1. So let's use an example of this in a problem. For example, air has a density, it's pretty low, of 0.0013 grams per milliliter. Let's convert 2 liters of air into grams. So essentially, how many grams would 2 liters of air weigh? Now, technically in this problem, you're going to be given the density and the 2 liters. And I've said always start with the number given, and technically there are 2 numbers given. But in this case, it's the liters that we're converting to grams. So that is what we want to start with. We're going to start with 2 liters. And I usually sometimes remind myself what we're converting to in the end, we want to get to grams. Now I know that liters has to cross cancel, and the only way to get from volume to mass is using the density. However, I can't use it now because I have to cross cancel liters. But what I can do is convert liters to milliliters so that I can then use the density. So this is what you have to pull out of your head. Every 1 liter is 1,000 milliliters. From there, I can use density. The density says every 1 milliliter is 0.0013 grams. Now I can stop and calculate. So I'll take 2 times 1,000 times 0.0013, and I should find that the air weighs 2.6 grams, which is pretty light and a number that we should expect because air is so light. All right, so that was an example of using a mixed unit and converting it to a conversion factor. Sometimes, however, we could start a dimensional analysis problem off with the mixed unit. So I think Usain Bolt actually ran as fast as 10.44 meters per second in some race that he's done. I can't recall exactly. And I am not a runner whatsoever, so I don't really know how fast that is. If I convert that to miles per hour, I'll have a better idea of how fast that is. So let's convert 10.44 meters per second to miles per hour. So in this case, we're actually starting off with a number that is a mixed unit, meters per second. The rule is that if you are starting off with a mixed unit, we must end in a mixed unit. Miles per hour, that is also a mixed unit. But when you're starting off with a mixed unit, don't write it out like this. You have to split up the units, one in the numerator, 1 in the denominator. Because in the end, if we're converting this to miles per hour, we are actually going to be converting meters to miles and then seconds to hours. And we can do that all in the same problem, but we're just going to take it one at a time. So I'm going to start with converting meters to miles. So I know that meters, it has to cross cancel. And if I look at my conversion chart, I can't find any direct conversion from meters to miles, but I do know that if I can go from meters to kilometers, then I can go from kilometers to miles. So there's 1,000 meters in a kilometer. My meters are gone and I'm in kilometers now. My next conversion factor says that every 1 kilometer is 0.62 miles. My kilometers have cross-canceled, and my top unit in my numerator is now in miles. So I have successfully converted meters to miles. What I have to do now is convert seconds to hours, and I could do that right here. Now, I don't know how many seconds are in an hour, but I know that there's 60 seconds in a minute. And I think carefully about how you're going to cross-cancel the seconds. The seconds is in the denominator. So it's going to cross-cancel with the seconds in the numerator. Every 60 seconds is 1 minute. Then, every 60 minutes is an hour. We are now left off with hours in our denominator, which is exactly what we want. We have miles in our numerator, which is exactly what we want. That's how we know we can stop the problem. So I'm going to take 10.44 divided by 1,000 times 0.62 times 60 times 60. And we should get 23.3 miles per hour, which is fast. Can you imagine running that fast? Because I definitely cannot. I can do a smooth maybe 6 miles per hour. All right, here's another example of starting with a mixed unit. I went to Iceland and they have the currency of krona, and it's a lot different from dollars. And when you go to buy gas, they don't give you the price per gallon, they give you the price in krona per liter, which is very confusing, and I have no idea what's going on. So using dimensional analysis in this case is actually very helpful. So let's say the price of gas, I think I looked it up, hopefully I looked it up properly, we'll find out if it makes sense in the end, that gas right now in Iceland is 234.1 krona per liter. Let's convert that to dollars per gallon. In order to do that, we need to know the conversion rate. Currently, it's 125.6 krona, and that's $1. So like I said, it's very different. Okay, so we're starting with a mixed unit, we're ending with a mixed unit. Make sure that we separate those units into the numerator and the denominator. So this is 234.1 krona over 1 liter. And remind ourselves in the end, we want to get to dollars over gallon. So we're going to convert krona to dollars, then liters to gallons. And we can do that separately, but in the same problem. So here's my conversion factor. Every 125.6 krona is $1. My kronas cancel. That's why I put it on bottom. All right, so I now have dollars on top. Now I need to go from liters to gallons. So if you guys look at the route that we could take on your conversion factor sheet, we can go from liters to quarts and then quarts to gallons. So that's what I'm going to do. My liters, though, has to go on top if it's going to cross cancel this liter on bottom. So on your conversion factor sheet, every 1 liter is 1.06 quarts. Your liters are gone, and now we're in quarts. but we want gallons. Every 4 quarts is a gallon. We end up with gallons on bottom, which is exactly where we want it, and dollars on top, which is, again, exactly where we want it, so we can stop the problem here. So I'm going to take 234.1 divided by 125.6 divided by 1.06 times 4. And you can see that the price per gallon is actually kind of expensive. About $7 per gallon, which it's an island. That makes sense. It was pretty pricey over there. So this concludes the video of using mixed units in dimensional analysis.